Hello, everyone, and welcome to our first day of video notes in Geometry B. Just a reminder, I'm Mr. Ward. I know we won't be able to meet each other for a little bit here, but I'll be your teacher during this unit and the rest of the trimester. I know it's kind of a weird start for us, but I'm really excited, and I think if we just work hard and we do what's best each and every day, I think we're going to get through this just fine. And so let's start with a little math here. In part one of our Unit 6 note packet, we're going to work on a skill just called simplifying radicals. This is not the main component of what we're trying to teach in Unit 6. However, it is an algebraic piece that arises from us doing some algebra with other geometry topics. And so it's going to be kind of how we conclude a lot of our problems. And so this skill is still important, and it's definitely a big part of the algebra we do in this chapter. Again, it's just kind of a day that will help us brush up on this skill, though, so we can use it in a geometry context later. So let's just start. Let's say we want to simplify this radical here, square root of 12. We could easily throw this into our calculator and get a decimal for it, but we want what's called an exact answer. And so we have to simplify this radical. And so remember, radicals, especially in this context, are really square roots. And so we can square root a perfect square without getting a decimal, but we can't square root non-perfect squares without getting a decimal. So our skill here is to take this square root of 12 and break it into two numbers that when you multiply them together, they still equal 12. So the value isn't changed, but one of those numbers is a perfect square. The other number is whatever else times that perfect square gives us 12. And then we can square root that perfect square. And so I want you to see how that works here. We can break square root of 12 into square root of 4 times 3. Again, 4 times 3 is still 12, so the value is the same here, but the difference is 4 is a perfect square. And so we can actually take the square root of that without getting a decimal. So as we step down to the next component here, one of the square root properties is we can put each of these numbers under their own square root. And the reason we want to do that is because now we are literally taking the square root of 4. And the reason we broke it into 4 times the square root of, or times 3 is because we can take that square root of 4 without a decimal. Square root of 4 is just 2 with no square root around anymore. And then the square root of 3 is not a perfect square, so it stays as a perfect, or it stays under the radical, under the square root. And this is our final answer. And so again, just to recap real quick, what we're trying to do is to break the number that's under the radical into two different numbers. One number that's a perfect square, which was 4, and another number that is a non-perfect square, but it's just, our perfect square times whatever other number will equal 12, so the value's not maintained, or so the value's maintained. And in this problem, that was 3. And then we can write them under their separate radicals so that we can eventually take the square root of that perfect square and write it without a square root around anymore. So let's do it with square root of 48. Again, we need two numbers here. One number being the biggest perfect square that goes into 48, the other being whatever the other number has to be. And so the biggest perfect square that goes into 48 is 16. Square root of 16 is 4. Well, 16 times 3 is what 48 is. So then again, we can write these under their own radical. So square root of 16 times square root of 3. And then we actually want to take the square root of 16 because it is just 4. And then the square root of 3 stays the square root of 3. So our final answer is 4 root 3. Now let's try that again with 20. Again, we want to break this into the biggest perfect square times whatever else. Biggest perfect square that goes into 20 is 4. So 20 is 4 times 5. And that'll be square root of 4 times square root of 5. And the square root of 4 is just 2. And so our final answer is 2 times the square root of 5. Now, real quick before we go on to the other things, it might be helpful to write these things down. Again, I keep saying we want to break these numbers into the biggest perfect square times whatever else. Here are our perfect square numbers. 1 times 1 is 1. 2 times 2 is 4. And remember, timesing by yourself is the same thing as squaring. So then 3 times 3, which is 3 squared, 9. And we get 4 squared, 16. And then we keep moving on. We're going to get 25, 36, 49, 64, 81, 100, blah, blah, blah. That brings us up to 10 squared, right? And so those are numbers we're going to be looking for as we break these into our first set of square roots that contain our biggest perfect square times whatever else. So let's work with that again now, and let's do number 7. Let's do it a little bit quicker here. So the biggest perfect square is going to be 9 here. So we'll break it in 9 times the square root of 2. You'll notice I skipped a step here. I just went straight to their own individual brackets. And then the square root of 9 is 3. Square root of 2 stays there. So square root of 18 becomes 3 root 2. Last one, for 60, we can break 60 up into 4 times 15. That's the best we can do. So this will equal square root of 4 times square root of 15. And the square root of 2, or 4 is just 2. So 2 times the square root of 15. Now, the other skill you'll see in this section of the note packet is what we call rationalizing the denominator. A square root number is an irrational number, and we just don't like them being written in the bottom of a fraction. And that's what we have here in 9 through 12. And so we want to write this in a different way so that there is no longer any square root in the bottom of the fraction. However, we can't change the value of this fraction. We can't change the value of whatever 10 divided by the square root of 3 is. We just have to write it in a way where there's no more square root under the bottom. So we're going to multiply this fraction by another fraction. And essentially, we have to multiply by 1. Because anytime we multiply by 1, 5 times 1, it equals 5. 8 times 1, it equals 8. 3.2 times 1 still equals 3.2. What I'm getting at is, anytime we times by 1, the value of what we had stays the same. But in this exact example, we want to times by a specific 1. And that specific 1 is going to be a fraction of whatever's in the bottom, so square root of 3, divided by itself. Square root of 3 divided by square root of 3 is going to be 1. Any number divided by itself is always 1. But we are just picking a specific version of what 1 is, and that's going to help us get that square root number out of the bottom. Now, let's figure out what this equals. Remember, anytime we multiply fractions together, we're just multiplying across. And so I need to do 10 times square root of 3. And don't overthink it. That is simply just 10 times the square root of 3 up top. And then we'll divide it. Now, square root of 3 times square root of 3, what we want to do is we want to multiply the 3's together, but keep the total underneath the square root still. So 3 times 3 is 9, but we want to keep it under the square root. And so square root of 3 times square root of 3 is square root of 9. Now, the last thing we need to do, is take care of the square root of 9 being down there. But you'll notice one of the reasons why we multiplied those two square root of 3's together is because square root of 9 now is an actual perfect square. And so we can write 10 root 3 on top, which can't be changed, but divide it by, and remember, square root of 9 actually equals 3. So we can write a 3 down on the bottom. Now, the last thing you'll need to check here is, can we actually divide these numbers without getting a decimal? Is 10 divided by 3 possible without getting a decimal? In this example, no, it's not. And so that's our final answer. Now, that might feel a little complicated, but essentially we just keep continuing that same thing. Whatever is in the bottom of our fraction, we're going to multiply by that number divided by itself and see what we get. So in this one, we have to multiply by the square root of 2 because the square root of 2 is in the bottom of our original denominator. And then we multiply across. So 8 times square root of 2 is 8 root 2. And then remember, we want to multiply the two numbers under our square root here. So 2 times 2 is 4, but then we keep that under the square root. But then the reason we do that is because that's now a perfect square. We can rewrite the square root of 4 as just 2. And so we can write 8 root 2 divided by 2 now. And then remember, just like in the last problem, the question is, can we divide this without getting a decimal? In the last problem, we could not. 10 divided by 3 did not work. But 8 divided by 2 does. 8 divided by 2 is just 4. And so notice we're going to write that as 4. And then the square root of 2 is a non-like term, so it just kind of stays there. And our final answer, 4 root 2. All right, let's do it again. Again, this time square root of 3 is in the bottom, so we're going to multiply by square root of 3 times over the square root of 3. Multiply across. It's going to give us 6 root 3 on top. Square root of 3 times square root of 3. Remember, 3 times 3 is 9, and then it's under the square root still. But then we can simplify that into square root of 6 times root 3 divided by, and again, the square root of 9 is just 3. And then check, can this be divided more? And yes, it can. 6 divided by 3 is 2. And the square root of 3 just stays attached. All right, one last problem. 7 times the square root of 2. Since square root of 2 is in the bottom, we're going to do the square root of 2 divided by the square root of 2. Multiply across, so we get 7 root 2 on top. Square root of 2 times square root of 2 is square root of 4. And then actually take that square root, it's going to give us 7 root 2 over 2. And can 7 and 2 be divided? No, it can't. So here is our final answer. All right, so just a reminder, you're going to definitely need to know these numbers here as we simplify these square roots. Definitely look back at this video if you need more guidance. I will also give a little bit of guidance in a separate video on some of our homework problems that you'll see as part of the Part 1 worksheet. Again, remember this is Part 1 in our Unit 6 note packet, and so this will correlate with anything else that says Part 1 in it. Thank you very much. Have a great day, and I'll talk to you soon in the Part 2 video.